Hi guys, and welcome to the video notes for Chapter 7, Lesson 2, Simplifying Algebraic Expressions. Please make sure you have the following paper in front of you. What will I learn? Today we're going to learn how to identify parts of an algebraic expression and how to use the distributive property to simplify algebraic expressions. So first of all, let's start off with some vocabulary. When an addition or subtraction sign separate an algebraic expression into parts, each part is called a term. The numerical part of a term that contains a variable is called the coefficient of the variable. So looking at the following expression, 3x plus 7 plus x plus 2. So if we're looking to identify how many terms this expression has, we are going to isolate each part with its sign. So this one, it has a 3x is a term, positive 7 is a term, positive x is a term, and positive 2 is a term. So there are 4 terms in this expression. The numerical part of the term that contains a variable is called the coefficient. So this one, we have 3 is an obvious coefficient. And actually there is another coefficient that's in front of, so let me just, 3 is the coefficient on that one. And then also remember, if there is a variable with no number in front of it, it has a coefficient of 1. So the coefficient for this term is 1. Like terms are terms that have the same variable part, such as 2n and 5n, or 6y and 4xy. And a term without a variable is called a constant. So we can use the following expression to help us isolate or to identify what like terms are and where the constant is. So first of all, I'm going to identify the terms. We have 5y as a term, positive 3 is a term, positive 2y is a term. So the like terms would be 5y and 2y because they have the same variable part. They both have a y. So those two are like terms. When we're talking about a constant is a term that does not have a variable part. So for this expression, the constant would be 3 because it is not being multiplied to a variable. It's just a number by itself. Turn the page. Make sure you have the following notes in front of you. Example 1. Identify the terms in the following expressions. Okay. So for this one, what I always like to do is I like to circle each term, and then so that makes it so that its sign is with it. So what I mean by that is this is 3m plus 5n minus 8m minus 4n. So the term is the whatever the number and variable or the constant, whatever it is, and the sign in front of it. So this one has a positive 3m, a positive 5n, a negative 8m, and a negative 4n. So we're going to start to kind of use negative and subtraction interchangeably with each other because they kind of mean the same thing. And then same with addition and positive, or plus and positive. They mean the same thing. So if I'm going to identify the terms, then I would go ahead and my terms would be, oops, let me fix that. The terms would be 3m, 5n, so positive 5n. This is a negative 8m and a negative 4n. For example B, my terms, I'm going to go ahead and circle them. I have a negative a positive 3b, a positive 2a, a negative 4, and a positive 5b. So my terms, negative a, positive 3b, that's a negative 2a, a negative 4, and a 5b. So those would be the terms with their signs. Example 2. Identify the like terms, coefficients, and constants in the following expressions. So first thing you want to do is go to your expression and just circle each term with its sign. So this one has a 3m, positive 5n, a negative 8m, and a negative 4n. So after I've done that, it just makes it a little bit easier to see all of my terms. So the first thing I want to do is identify the like terms. So the like terms have the same variable part. So we have a 3m, and hold on, I can't really see this. Let me erase. Oops. Didn't mean to do that. Okay. Okay, so my like terms, I have a 3m is a like term with negative 8m. And then also I have positive 5n, and its like term is negative 4n. Now coefficients are just the number part when a number is being multiplied to the variable. So for 3 times m, 3 is the coefficient. For 5 times n, 5 is the coefficient. For negative 8m, negative 8 is the coefficient. And then for negative 4n, negative 4 is the coefficient. In regards to constants, on this one, there is no term that does not have a variable attached to it, so our constants would be none. For b, we have negative a plus 3b plus 2a minus 4 plus 5b. So circle each of your terms. I'm going to try to do it so I don't write over it, which I already did. Okay, so like terms have the same variable part. So in regards to like terms, starting with a negative a, I see a 2a. So we'll have negative a is like terms with 2a. And then I also see positive 3b and positive 5b. Let me fit that. Those are like terms. And then I have this negative 4. There's not another constant, so it doesn't have any like terms with it. Coefficients, the number part attached to the variable. So just looking above, this negative a, remember when a variable doesn't have a number coefficient in front of it, there is that invisible 1. So the coefficients would be negative 1, positive 2, positive 3, positive 5, and then constants, the only one without a variable attached is negative 4. Go ahead and try the practice problems below where you're going to identify the terms, like terms, coefficients, and constants in each. So for the part where you are identifying the terms, how you should organize this is you want to make it very organized. So what we should see, what to help you, just start, write terms, and then we have a spot for like terms. Then we'll have a spot for coefficients, and you'll list all of them, and then for constants. So much like we just did up above here where you had those lines. An algebraic expression is in simplest form if it has no like terms and no parentheses. So simplest form means no like terms, no parentheses. When you use the distributive property to combine like terms, you are simplifying the expression. So that's what we're going to do in the next part. We're going to combine like terms, and if there's distributive property, we're going to use the distributive property and then combine like terms. So with these, when we're solving, again, the first thing I like to do is I like to circle my like terms. Or I'm sorry, circle my terms. So for example, on this first one, we have 3m, we have positive 5n, we have negative 8m, and negative 4n. So the next step of what I should do is I should write my like terms next to each other before I start combining them. So this 3m, I'm going to keep it right there. And then I see another term that has is a like term because it has the same variable part, is the negative 8m. And then I have a positive 5n and then a negative 4n. So now I just kind of moved the like terms next to each other. So when I'm combining a positive 3 and a negative 8, the signs are different, so I want to keep the sign of the larger absolute value and subtract. So 8 minus 3 is 5m. And then with positive 5n, negative 4n, signs are different. Keep the sign of the larger absolute value and subtract. And I'll end up with negative 5m plus n. B. Start by circling your terms. I have a negative a, positive 3b, positive 2a, a negative 4, and a positive 5b. So first thing I want to do is I want to write my like terms next to each other. So I am going to write negative a, and then I see over here a positive 2a. And then I see a positive 3b that I'm going to write next to a positive 5b, and then I have my constant of negative 4. So combining my negative a and positive 2a, this is like a negative 1a. So signs are different. Keep the sign of the larger absolute value and subtract, and I get 1a, or a by itself. Next one, positive 3b and a 5b is a positive 8b. And then my constant, minus 4. And usually when you're writing your expressions, we write it in alphabetical order. So we would want the a to come first and then the variable b, because that's how it comes in alphabetical order. Example C, we have 4 times the quantity q plus 8 times p plus 2 times p. So this is one where we have the distributive property. So before we start moving terms around so that their like terms are next to each other and simplifying, we have to use the distributive property to break the q plus 8p out of the parentheses. So I'm going to multiply 4 times q and 4 times positive 8p, and so I'll have 4 times q is 4 times q, and 4 times 8p is 32p, and then bring down the plus 2p. I don't really have to organize anything here because the like terms are next to each other. 32p and 2p are like terms because they have the same variable part, so we'll have 34p. And bring down the 4q. So simplified 4q plus 34p. Example D. I have negative, and then in parentheses 3c minus 4d, close parentheses, minus 2c minus 8d. So before I start moving around to get my like terms next to each other, I need to distribute this negative, or negative 1, to the terms inside the parentheses. So I'm going to do negative 1 times 3c, which gives me a negative 3c. And then I'm going to do negative 1 times this, think of this as a negative 4d. So negative times a negative is a positive, and 1 times 4 is 4d. And then just write everything else as it was. So my like terms would be negative 3c, and there's a negative 2c. There's a positive 4d, and there's a negative 8d. So combining a negative 3c and negative 2c is a negative 5c times c. And then a positive 4 and a negative 8, you want to keep the sign of the larger absolute value, which is negative, and subtract, and we'll get negative 4d. So this is my answer. Go ahead and finish the practice problems, and we will go over these tomorrow in class.